up? In this lesson, we'll be covering the Hackerrank easy rated algorithm called Save the Prisoner. In this kind of sick problem, we have a scenario where a prison guard is handing out sweets to some prisoners. In this example, we have 4 as the number of prisoners and 6 as the number of sweets. And 2 is actually the chair of the prisoner that the guard starts with, giving the candies at. So essentially, you've got four prisoners, and each prisoner will have a seat assigned to them. They would have seats 1, 2, 3, and 4. And we're going to start at prisoner 2 and start handing out our 6 treats, or 6 candies. So you would give out a candy until you got to the end of the row, increasing in chair number, and then loop back around to the beginning of the seating arrangement. So the prison guard hands out the candies, and the last candy is given to prisoner number 3, sitting in chair number 3. And the goal of this question is to find the last individual to receive the candy, because the candy actually tastes really bad and you want to save the prisoner. So, weird question. Why a prisoner guard is giving out candies and a bad one, I don't know. And why this is considered saving the prisoner instead of, maybe letting the prisoner out of jail being saving the prisoner, I don't know. But we will move over to Replit and start to get to work on this question. So we've got our variables, or our parameters, defined up here. We'll have 5 prisoners, 2 suites, and we'll be starting with the first chair. So one way to do this would be to make an array of all of your prisoners, and then move through the array for the number of suites that you have, and then identify that prisoner that received the last treat. And you could think that if there were a lot of suites, well, an array that just went up to your prisoner wouldn't suffice. You'd have to do it multiple times. So if there were 8 suites, you'd need an array that looped through all of the prisoners twice, because you'd have to hand out 8. You would start giving multiple treats to multiple people, and you would need to find the last one. So the last prisoner to receive in that case would be further in the array than we could manage if we just had an array of 5 prisoners. So the reason we won't be doing that is you could do that and it would actually pass this sample test, but the issue is that in the test cases on this question, the numbers start to get really, really big, and there starts to be a lot of tests that happen. And if you were to do that, you would run into a runtime error. So we need to come up with code that's a bit more simple than that. Okay, so we need to find the individual who's receiving the candy, right? We can go ahead and set them as a variable. And what do we need to do? Well, we start with the first chair, and we hand out some sweets. We give the first chair a sweet, and then we move to the next chair, and we hand them a sweet. So mathematically, you could think, well, in this case, you would only give the first 2 chairs a sweet, right? So to mathematically represent that, we can write S plus M minus 1 will give you the last prisoner to receive a treat. Sweet treat. I'm sure my dog right next to me is going crazy. Sorry to him. But so this is how we would mathematically represent the last prisoner to receive a treat. So prisoner 1 receives the first one. We are handing out 2. Prisoner 1 and prisoner 2 get it. And what's that math? 1 plus 2 equals 3, minus 1, 2. Prisoner 2 is the last to receive a treat. Okay, so that gives us our last prisoner to receive a treat. But as I mentioned just a little while ago, if there were many, many treats being given out, say we're giving out 20 treats, well, that wouldn't give us our answer. It would be 1 plus 20 minus 1 equals prisoner 20, there is no prisoner 20. There's only prisoners up to 5. So what we would actually do is take the modulo of the number of prisoners. Essentially, it's how many times did you loop through. The remainder is what you really need. The remainder will show the last prisoner to receive a treat. Because think about it, you have multiples of 5 treats at that point. And then you can give them out multiple times, and then you have a few left over to again start to loop through your prisoners, but not finish looping through your prisoners. And that is the remainder. So this math right here will give us our remainder. But there is one caveat. We can wind up in scenarios where this equates to 0. And if this equated to 0, what does that mean? Well, that means that this number is evenly divisible by our n. So who would then get the candy? Well, if it's equal to a number that's divisible by 5, that means that it's actually the last prisoner. It's prisoner 5 who gets the treat. But how could we write this? Well, we can go ahead and set a variable of answer equal to 0. And we can then say if our received variable, our last prisoner to receive the number, or to receive the sweet, if this is equal to 0, then our answer will be set to n. Really, you could just leave the answer. You could just do return answer. And why would that be? Because answer is 0. And why is answer 0? Or no, we can't do that. I apologize. We need to return n. Because answer is the last prisoner, and answer needs to be, well, we don't even need answer. We can just return n. Okay, and else, what would we do? Else, we would return our answer that we found here. So we would return received, or last prisoner to receive. Okay, so we can go ahead and copy this over to Hackerrank. I think I copied the whole thing. I did, great. We'll put this in Hackerrank format, which is just like that. And let's run the code, see if we've got it working. Awesome, so we passed both sample test cases. Let's go ahead and submit the code, see if we passed all of our test cases. And there goes my computer fan. Okay, there we go. Obviously need a new computer. I know. Drop that down in the comments if you think so. But yeah, that's it. So this is a relatively simple question. I totally understand if you were to take that first approach that I mentioned that runs you into a runtime error. This is the simplified version, the version that's going to save you a bunch of computing power. So I hope this is clear. I hope you enjoyed this video. If you did, go ahead and hit the like button. I post these videos all the time, so if you're into algorithms, Hackerrank questions, go ahead and hit subscribe. And thank you for watching. Hope you have a good one.